Okay, so now in 10.3, we're going to be comparing two independent population proportions. So a hypothesis test can help determine if a difference in the estimated proportions reflects a difference in the population proportions. The difference of two proportions follows an approximate normal distribution. Generally, the null hypothesis states that the two population proportions are equal. And there's, two ways to kind of express that. Like the null hypothesis, where population A is equal to population B, or the null hypothesis is that the difference of the proportion of population A minus the proportion of population B is equal to 0. But if the difference of proportions was actually difference to, if the difference was anything other than 0, then this is how you'd write it up above. When comparing two independent population proportions, several criteria need to be considered. The two independent samples are simple random samples. The number of successes is at least 5, and the number of failures is at least 5 for each of the two samples. And the population must be at least 10 to 20 times the size of the sample. This procedure prevents the population from being oversampled and causing incorrect results. So let's look at our first example here. So this is cars in Connecticut and New York with rear license plates only. So here we've got a table where we've got the two states, Connecticut and New York, with a sample where some cars had rear license plates only. Okay, we have a frequency for both states, and then we have a front and rear license plate on a car, and we have a frequency for each of those. So use a 95% confidence level, test the claim that Connecticut and New York have the same proportion of cars with rear license plates only. So we're going to consider a success is a car with a rear license plate only. Okay, so let's kind of take a look, at this problem. And I've already kind of started to break this down so that we can kind of look at this table and glean some information from it for this type of hypothesis test. So let's, before I get into this stuff up here, let's maybe kind of define a couple of things. So we have a proportion for Connecticut. Okay, so that's going to be the population proportion of cars in Connecticut with rear license plates only. And let me actually rewrite that just a little bit because I want to leave myself some room off to the side here. Okay, so with rear license plates only. All right. And so we're going to refer to that as proportion 1. Now, we took a sample from this population. All right, and that's composed of the number of successes over the total sample size. All right, so now if we are considering that rear license plates only are considered a success, okay, then X1 is going to be this value of 239. And then what is N1 going to be? So N1 is the total sample size of Connecticut. So the total sample size of Connecticut is going to be both rear license plates and front and rear license plate cars. So it's going to be 239 plus 1,810 or 2,049. All right, so I don't think it's going to be necessary for us to actually calculate this sample proportion value. But I kind of want to show how, the population proportion and the sample proportion from that population, how they're kind of related. Okay. If we were going to continue with maybe this labeling, we'd end up labeling this P prime sub 1, something like that. Okay, now we've got the population proportion from New York. That's the population proportion of cars in New York with front and rear license plates. And we're going to label that P sub 2. And we did take a sample from New York, so that would be the sample proportion from New York would be the number of successes over the number of failures. I'm sorry, not the number of failures, but the sample size. And so the number of successes that we had in New York was 9. And the sample size is going to be 9 plus 541, which comes out to 550. And if we were going to label this as well, we would say that this is the sample proportion from population 2. Okay, so yeah, we're not going to need to actually calculate this proportion, but what you'll notice here is that we're going to be using a calculator function, which is a 2-proportion z-test. And I'm trying to scroll down, there we go. And you can see that it requires the number of successes and the sample size from the first sample. So that's going to be these values. And then the other part it needs is the number of successes and the sample size from the second sample, which will be those values and those values. All right. Okay. So we've been able to, take the data, kind of break it down into its component parts. And let's see, what else do we need? Oh yeah, the confidence level. So the confidence level, by the way, this is step 1. So these are our given information. Our confidence level is 0.95, which means we're going to have a significance level of 0.05. And if we need to split that into 2 tails, we're going to have a significance level of 0.025. All right. Now, step 2. Actually, before we move into step 2, we actually have to write down our claim. So let's do that. So it says, test the claim that Connecticut and New York have the same proportion of cars with rear license plates only. So what that's saying is that the population proportion for Connecticut is equal to the population proportion to New York. Yeah, that's going to be our original claim. Okay. So I think now we've got everything we need to move on to step 2. Don't like that it does that. All right. So step 2 is to set up the null and the alternate hypotheses. So we have this claim here, and that is our original claim. All right, so what's the complement to this? The complement is not equal. And remember that the null hypothesis always has an equality. So the other claim has to be the alternate hypothesis. And the alternate hypothesis dictates whether we're dealing with a left tail, a right tail distribution, or a two-tailed distribution, in which case not equals means two-tailed. All right, so I think that's everything that we need to set up here in step 2. Step 3 is going to be to calculate our test statistic and the p-value. Again, this is from our sample data. And that's where we use the calculator functions here. All right, so we're going to have a z test statistic, and we're going to have a p-value related to it. So let's go up here to our calculator functions that we're going to use. So we're going to use a two-proportion z-test with the Texas Instruments calculator. So like I mentioned, we'll be putting in the values 239, 2049, 9, and 550. And then our alternate hypothesis here, okay, that's what the calculator function wants. So that's going to be not equal to P2. With the NumWorks calculator, we're going to go to the Inference app, choose a two-sample proportion, and that's going to be a two-sample proportion z-test. So what we're claiming is that the difference between the two populations is 0. Okay, which is kind of what we got, actually, is what we got going on here. And the alternate hypothesis is not equal to. Okay. And yeah, then the same values. X1, which is the number of successes in Connecticut, that's 239. Sample size was 2049. Sample size, or I'm sorry, the number of successes in the second sample is 9, with a sample size of 550, and a significance level of 0.05. All right, yeah, so I think that's it there. So let's go ahead and flip on over to okay, let's flip on over to where did those go? All right, let's flip over to the calculator. And let's see here. We need to go to tests. Oops, I don't want a z-test. Okay, I need a two-proportion z-test right there. All right, let me go back over here. And I just want to make sure. All right. That's weird. All right. So I just want to get these values showing. All right. So X1 was 239. Sample size was 2049. Okay. Number of successes in the second sample was 9. Sample size was 550. Okay. Alternate hypothesis was not equal to. Go down to calculate. So I'm going to hold off on that because I need to enter these values into the NumWorks calculator. So let me go down to inference. We want to do a test. Now we've got two proportions this time. We want to do a two proportion z-test. All right. So the null hypothesis is that the difference is zero, meaning there's no difference between the two populations. The alternate hypothesis is not equal to, so that looks like that's already correct. If I had these other options, I want to make sure that one is selected. So go next. Okay, number of successes is 239. Then 2049 for the sample size. And then the number of successes in the second sample was 9 with a sample size of 550. Significance level of 5% or 0.05. That's correct. Click next. All right. So it gives us the proportions. Let's see here. Okay, so there's our test statistic and our p-value. So our test statistic is positive 7.11. And let's come over here to the Texas Instruments. Let's calculate that. And what's interesting is that the NumWorks test statistic and the Texas Instruments test statistic are the same, but the p-values are a little different. Can't really explain that, but anyway, let's go ahead and write those down. It's not going to make a difference because these p-values are ridiculously small, right? This e minus 12 means it's 10 to the minus 12. All right, so that's a really, really small area. Okay, so what we've got is we have a test statistic of 7.11, and on the Texas Instruments calculator, we have a p-value of 1.19. I'll just put 0.5 times 10 to the minus 12. And on the NumWorks, we've got 1.1824 approximately, also times 10 to the minus 12. So those are just two ridiculously small areas because of that 10 to the minus 12. So I think now we can move on to the next step, step 4, which is to sketch our distribution. Okay, but just so that we have it handy, or I have it handy, I'm going to write down our test statistic here. And the p-value, I'm just going to round it because it's about the same to 1.2 times 10 to the minus 12. I mean, it's not really going to matter because of this 10 to the minus 12. I guess just to kind of refresh your memory, how small is that really? So what we do is you put down 1.2, and now we need to move the decimal place 12 spaces to the left because we have to move in the negative direction. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 12, put my new decimal point, and everywhere that I had a skip, I have to put in a 0. So you see what I was saying about that being ridiculously small? Say my tablet. Oh, there we go. So let me see if I can. Tablet's frozen again. This feels like maybe my tablet's overheating a little bit. Okay. So I'm trying to erase these down here. There we go. And then we'll erase this old decimal place. So you can see that's a really small area. Okay. All right. So since we're dealing with proportions, we're going to have a normal distribution. So let's just go ahead and draw that in. And before I forget, step 4. So this is to sketch our distribution. So we got a normal distribution, okay, where the center has a z-score of 0. And this is two-tailed, okay, because that's what the alternate hypothesis told us. So that means we're going to have a positive z critical value and a negative z critical value. We had a confidence level of 0.95. And since we have two tails, we have a alpha divided by 2 area of 0.025 in this tail. And alpha over 2, we've got 0.025 with an area in this tail of 2.5%. Okay, and the region over the tail, that's the reject the null region. And between the two critical values, that's where you fail to reject the null. Now we need to figure out where this z-test value is going to fall relative to this picture. So that's what inverse norm is for, because with inverse norm, we're going to take the significance level area. Actually, this time, because it's two-tailed, I'm just going to go ahead and use the confidence level area to get my negative z critical score and the positive z critical score. They're going to be the same. I'm just changing it up a little bit here. So we're going to have an area of 0.95 with a mean of 0 and a standard deviation of 1. And we're going to look at the area in the center. With the NumWorks calculator, distributions app, normal distribution, mean of 0, standard deviation of 1, area in the middle, and an area of 0.95. And that's going to give us a positive and negative z critical value. So let's go ahead and do that. So we need to go to the distribution functions, go to inverse norm, an area of 0.95, 0 and 1, area in the center. Okay, let me hold off on that. NumWorks, I'm going to back out of this. Okay, so that I can come to the distributions app, go to normal, mean of 0, standard deviation of 1. Okay, I want the area in the middle with an area of 0.95. Okay, and that gives me positive and negative 1.96. And we should get the same thing here on the Texas Instruments. Yep, positive and negative 1.96. So this critical value is positive 1.96 and negative 1.96. So where is our test statistic on this scale? Well, a value of 7, positive 7, I might add, is to the right of 1.96. So, I'm just going to draw the test statistic here to the right of the critical value, and that's 7.11. And if I draw straight up from that, that firmly puts us in the reject the null region. And our p-value is the area in the tail. And that was 1.2 times 10 to the negative 12. And this value is far smaller, okay, than this area in the tail. All right. So that immediately takes us to step 5, which is to put together our results and write our conclusion. So here in the end, we are rejecting the null, and that's going to be coupled with, let's see, what was our original claim? So our original claim was the null hypothesis. Okay. So the null hypothesis was the original claim. So down here in our conclusion table, the null is the original claim, and we're going to reject the null. Okay, so the null hypothesis again was that there's nothing new here. Like we already know that the two proportions of rear license plates are the same in the population of cars in Connecticut and New York. That's what the original claim is. Nothing new to learn here. Everything's situation normal. Everything is equal. But we learned that we need to reject that null hypothesis. That null hypothesis is wrong. So we're going to say there is sufficient evidence to support rejection of the claim. Okay, so let's start writing. This is our conclusion. There is sufficient evidence to support rejection of the claim that, okay, so now we need to put in our claim. Trying to switch pen colors here. Okay, that Connecticut and New York have equal proportions of cars with rear license plates only. And then we have to put the confidence level or significance level that we use for this hypothesis test. So we're going to say with a 95% confidence level. Just like that. All right, so we are done with this hypothesis test. Let me know if you have any questions.